Today's agenda will be focused on detailed application performance monitoring, that is analyzing different transactions taking place on your application side and using these transactions to understand how optimal the performance is for your end users with respect to your applications. So we will drill down to the individual queries that contribute to irregular application performance. We will also see the JVM performance metrics of all your applications based on Java. And then we will also take a look at the Java runtime monitor, which could be of real use to monitor Java-based applications that are developed in-house within your organization. So the first item on today's agenda, that is deep diagnostic capabilities to debug transaction problems. Before we move into this aspect of application monitoring, let us first visualize this web application architecture, wherein in the first session, we focused on this part, that is the infrastructure part and how you can utilize Applications Manager to collect various critical performance metrics of your servers. Today, we will be focusing on the central area, which is about web applications. And as you can see, web applications based on Java, .NET, and Rails, Ruby on Rails, are the ones that Applications Manager can collect detailed parameters for. Finally, we will also see end user experience monitoring with Applications Manager, and we will conclude the webinar series by looking at some administrative functions. So as I just mentioned, the APM Insight module, that is the module responsible for the application performance monitoring parameters in Applications Manager, is available for Java-based applications, .NET-based applications, and applications based on Ruby on Rails. Soon we will also be supporting all applications based on PHP and Node.js as well. Why do we need application performance monitoring? In fact, well, to answer this question, it is quite obvious that server-side problems require server-side monitoring, which means the parameters that we monitor for each of our applications on the surface, that is the CPU or the disk IO or the memory metrics, these alone cannot be sufficient when you consider monitoring from an applications team perspective. That is, it is important to understand, to dig deeper into the transactional information. That is when we have end-to-end visibility right from the URL to the SQL statements that are in fact causing an irregular performance. Transaction profiling allows us to collect all these transaction traces within the product so we can analyze the slow performing transactions and then resolve these issues in time before they start to pose a threat to service delivery. We will also be required to track connected database operations, wherein we can find out the slow database calls happening on the database side and how fast information retrieval happens for a user when he accesses the application from the UI. So going forward, how do we measure end user satisfaction levels, or what metric do we use to gauge how happy your customers or users are with respect to your application performance? So the metrics used here is the AppDex score, which is an industry-wide open standard that ranges from 0 to 1. And this could be a very clear indication of how optimal the application performance is. In fact, any score that is upwards of 0.7, 0.8 is indicative of an extremely well-performing application, and anything below 0.5 requires us to immediately get all hands on deck and diagnose and resolve application issues. The APM Insight module requires an agent to be configured. This agent then communicates with the application server and then collects the data and pushes it to the central Applications Manager console. And this agent configuration is where we specify the thresholds to generate stack traces, transaction traces, to calculate the AppDex score, and even to specify how often this data has to be pushed within the product UI. One more slide about the agent configuration, and then we will see in real time how this agent has to be configured so as to ensure data collection happens smoothly. If you see the highlighted box, the first box tells us the location where we have to specify the host name, where the applications manager product is running, and below it is the location where we specify the port number of your applications manager instance. Now remember, every time you install this agent has to be saved in the same machine where your application server is running. That is how you ensure that the connection between the application server and the agent is established. So let us now move away from the presentation and see how the agent configuration has to be done. For today's demonstration, we will be using the Java agent, and we will see how this Java agent can be used to collect detailed performance metrics of your Java applications. Right here, if you can see my screen, this is where you download the agents from. A simple Google search with the term Applications Manager APM Insight should show you links, the first of which brings you to this page where you can download the Java agent right over here, the .NET agent over here, and the Ruby on Rails agent over here. So all you have to do is unzip this file, and again remember, this agent has to reside in the same system where your application server is residing as well. So once you have saved this, right here I've already installed the agent, and the APM Insight conf file is the file where you specify the configuration details of your agent. You can call your application by any name that you desire to have, the host name, the port name, and in fact if you scroll further down you will find where to specify the transaction traces, the AppDex threshold, and the error trace thresholds as well. Now, in case you want to run it on a different port, because by default Applications Manager takes the web server port, in case you want to enable SSL authentication, you will have to change this value to true and then specify the port number over here. So once the agent configuration is done, the next thing that we have to do is make sure that this agent is hooked up with your application server. So today we are going to use a Tomcat server as our Java application. So right here is the Tomcat server configuration window. Under the Java tab argument section, I have specified the agent path. Right here, if you notice, is the agent path of my Java agent. Now remember, I'm only specifying the agent path in the application server configuration window because I'm going to start the Tomcat server from services over here. In case you're going to start it using a batch file, then the path goes into the startup file of your application server. That is another point that you need to remember. Now, once the agent is configured, I close the windows. And remember, once you have established this connection, you have to restart your application server. Only then the connection gets securely established. Going back to the presentation, so we can see a few more slides about the kind of information that we can visualize with this agent, and then again we'll come back to the product to see them in real time. So this screen over here is that of the APM Insight Overview tab. The Overview tab gives us a summarized view of all of the different performance parameters that could be of real importance to us, which is the average response time and average response time broken by tiers, which means the different elements that comprise your individual transactions. The response time for all of those elements are also captured here for easy access. Some more information include transactional information such as information about erroneous transactions, about slow transactions, the recent slow transactions or the top transactions based on error, and some more information in the web transaction tab, which is on your left. If you notice, these are all the individual transactions that take place on the application server side, and for each of these transactions on the right is the corresponding component wise split up of that transaction. So what percentage of this transaction comprises of servlets, how much of it is filters. So this also gives us an idea into the different components involved in a transaction and just which component is contributing to the delayed response. As I mentioned, the different elements of these transactions can also be visualized, and as you can see, the different components like servlets, ASPX, filters, JSPs, what is the response time for these elements. So this kind of information is what is really useful to applications and DevOps teams working on the development cycle. So let us go back to the product right here. As I mentioned, today we'll be using Apache Tomcat as our Java application for which we will be collecting metrics. So here is my Apache Tomcat server, and what I have done is I have hosted my own application, online application on this application server. Now imagine this as an online shopping store where I'm going to perform some transactions, putting myself in place of an end user. So for all of these transactions, we should be able to visualize the data inside the product UI. So I'm going to enter the store and I'm going to perform a few transactions. So I'm performing a few random transactions, and we will see whether this data is collected by the agent and pushed to the product UI. All right, so I'll go back to the product UI, APM Insight right over here, my application, and there we have the information pertaining to the transactions that we just made. So it will take the agent a minute to collect all the data and populate it within the product. As you can see here, the Apdex score, Apdex response times, and since we haven't had any slow transactions or error transactions yet, there aren't any, but we will soon be performing these transactions as well and see them get populated here. So let me just click on the web transaction tab, and right here, these are some of the transactions that we just performed and the product has captured it over here. So as I mentioned, when I click on the particular transaction on my right, I find the details of that transaction. I click on another transaction and subsequent details are available here. Transaction Apdex score, transaction response time by components, transaction response time and throughput. I can sort these transactions based upon the most time consuming ones, based upon throughput, and based upon the transactions that have errors. So let us go back again to the presentation, continue where we left off, and then we will return to the product again to see more about the rest of the tabs over here. Right, so the next item on today's agenda is identifying the root cause to the individual line of code. Now what this essentially means is every time your application server sends some request to the database, it is also imperative for you as service providers, as vendors, to monitor these transactions as well. How fast is your database response? How to identify the slow database calls? And how to make use of traces to identify the transactions that are consuming more time. So ideally, the traces are generated based upon the thresholds that we configure. That is, each time the configure threshold is violated, the traces are captured and displayed in this tab over here. The trace details of the slow transactions are also available upon probing further, as you can see from this screen. So these are all the slow transactions and their traces, and then we also can see the slow SQL statements from this tab over here. Now it is important not just to monitor the slow SQL statements. The next slide will show you that the background transactions are also captured with the help of this agent. So what this essentially means is, if you're communicating with the application server with the help of certain REST APIs, so these background transactions are also captured. So this is basically end-to-end visibility right from the UI to the database calls that are involved in fetching and displaying the required information. And as you can see, when you analyze all of this and put all of them together, it helps you to directly pinpoint application errors, and furthermore, the stack trace of these erroneous transactions tell us how to resolve or where the issue is and gets us into the troubleshooting mode soon. This basically allows us to eliminate the time wasted in diagnosing an issue and eliminates our dependency on customers to inform us about such issues. So it allows teams to be proactive when it comes to diagnosing and troubleshooting issues and always ensuring uninterrupted and seamless delivery of services. I'll go back to the product, and what we are going to do now is go back to the online store application that we have. But this time, what we are going to do is assume this real scenario. Let us assume this is my online application and there is an online sale going on. So naturally, what I would expect during such a scenario is a huge surge in the traffic to my site. Now, this huge surge in traffic would mean a lot more transactions. So among this multitude of transactions, users might face several different kinds of errors. Now, for example, right here, I'm going to deliberately create an error. Now, this screen right here shows me the stack trace of this error. Now, this is just one of the errors that your user is likely to incur. But then there could be several different errors. And how often do we actually hear from our customers about such errors? In fact, that is why it is imperative that we be proactive and detect these errors instead of having our customers complain about these errors. In fact, here's a startling statistic for you. A recent survey by Google reveals that 53% of users, in fact, drop off from a site if the response time is beyond 3 seconds. Now, the fact that more than half of the users arriving at your site are most likely to drop off if the response time is more than 3 seconds is itself a shocking statistic, which gives us more reason to always monitor our web transactions and stay ahead of performance problems. So since we have performed this error, we should be able to see these error traces inside the product as well. All right, so I'm going to jump to the product again, and I'm going to show you the error traces over here. So right here, if you see the error, the first error that we had seen, the transaction is here. And for that particular error, I can see the trace details over here, the trace details, the SQL statements over here, and finally the stack trace for that particular error with the error message right here. So now it becomes increasingly clearer, I believe, how these errors can be captured before the end user experiences them, in fact. And let me just quickly show you some other tabs as well that we discussed. The database tab, wherein we can see the transactions taking place on the database side with similar information on the right hand side as we saw for web transactions taking place on the UI side. Right here is the background transaction. So we don't have any background transactions right now, so there isn't any data, but you should be able to see those data about background transactions over here. Trace details over here. So these transactions have violated the configured threshold, and therefore these transaction traces are available over here. And again, for these traces as well, the trace details and SQL statements can be visualized from these tabs. So I believe the transactional information and the error traces, how to analyze them and how to configure the agent to populate this data has become clearer. Let us get back to the presentation and see some more slides about the APM Insight module. We now arrive at the third item on today's agenda, which is basically some more insights into your Java applications. So we spoke in the beginning that the APM Insight module is available for .NET, Java, and Ruby on Rails. We will share in the chat panel the link to APM Insight for .NET applications that we had presented last year during our webinar series. You should be able to understand how the configuration and data collection happens for .NET applications through that video. However, let us now move ahead and see the kind of information we can visualize for Java applications beyond what we have already seen. So some of these information include the JVM summary. This is just like the overview tab of the entire APM Insight. In fact, this gives us an overview about the JVM of your Java application. And some metrics that we capture include the CPU usage, the heap and non-heap memory, thread details, which are in fact very crucial when it comes to Java applications, garbage collection, which is just as important, configuration details, and so on. Allow me to walk you through a few more slides about the JVM metrics before we go back to the product and see them in real time. So the garbage collection metrics are represented like this in a graphical format, and the thread details are also captured with information pertaining to the status of threads, such as whether the thread is live, whether they are sleeping threads, whether there are deadlock threads, and such information about thread and garbage collection are also available. So allow me to show this to you in the product. Now, if you had noticed, we covered, in fact, we saw all of these tabs except the JVM tab. And when you click on the JVM tab, we should be able to visualize the data that we just saw moments ago in the presentation. So the JVM CPU usage, the runtime memory, heap, non-heap memory, JVM classes count, all of the detail that the application team, the DevOps team would require are available here. And the garbage collector details for both scavenge as well as mark sweep are available over here. The thread details can be seen from the threads tab. And finally, the configuration details can be seen here from the configuration tab. So this gives us detailed information about the configuration of your JVM, what version this JVM is, the Java arguments used, and the host details of this Java application, including the memory details. So this is about JVM of your Java application. In this case, the Tomcat server that we have been using for today's presentation. Back to the presentation, which brings us to the final item on today's webinar agenda, which is the Java Runtime Monitor. So the need for Java Runtime Monitor, in fact, is when you have this requirement to monitor the applications developed in-house using the Java technology. Now, for all applications using Java 1.5 and above, the Java Runtime Monitor collects performance parameters with extensive details, and even allowing you to visualize garbage collection and thread details as we saw in the APM Insight module. But the Java Runtime Monitor, in fact, takes it to a deeper level in terms of the actions it allows us to perform and the metrics it allows us to visualize. Some of the metrics are right here on this screen. The following screen shows us some metrics about garbage collection, and if you see right here, if you follow my cursor, the product allows you to perform one-click garbage collection right from the UI. It allows you to see the impact of these garbage collection activities on your mark sweep and your scavenge. And similarly, it also allows us to instantly trigger thread dump generation from a click of a button from the UI, because quite often what happens is you will have to analyze your log files, and then from the multitude of log entries you will have to understand which threads have contributed to an irregular app performance. But then instead of having to analyze your log files, a simple one-click thread dump generation and heap dump generation reduces the time spent on these resolution factors. Now I'm going to take you to the product one last time to show how the Java Runtime Monitor is configured and the kind of data it collects. So right here, new monitor, add new monitor, and under the application servers category is the Java Runtime Monitor. So I'm going to create a sample monitor, specify the host name, the port number. Now let me test the credentials. So it's all good to go. I click on add monitors and I get the success message that my Java Runtime Monitor has been successfully added. Now let us see the kind of details that we were speaking about in the slide. I'm going to poll this monitor a few times so we have enough data to talk about. All right, so here is the overview tab where we see about the Java Runtime Monitor, the connection time, the memory usage, the system memory, process memory, basically all the necessary information that we would require as IT people working in Java applications. Again, as I mentioned previously, it is very important to use the Java Runtime Monitor to monitor applications built in-house, so you have end-to-end visibility, the same kind of visibility that you would have for your other critical applications. The garbage collection details are available over here. If I click this, the performed Java garbage collection has been successfully triggered. Similarly, the impact of garbage collector, as I said in the slide, can be seen here. And the thread tab should allow us to instantly view the thread dump upon clicking this icon over here. So here you can see the individual thread names along with their status and all the details pertaining to all of these threads involved. And of course, like any other monitor, the product allows you the flexibility to configure thresholds for individual attributes and associate them with alarms. So each time a threshold is violated, you are always kept informed about these changes. The configuration details about your Java Runtime Monitor can be seen from the configuration tab right here, and the actions tab should allow you to perform these actions from a single screen: the garbage collection, the heap dump, and the thread dump. And in the actions tab over here, if you notice, we provide the Java heap dump, thread dump, and garbage collection actions as automated actions. So for applications built on Java, if there is an error that is triggered, you can associate that error with these actions so as to automate this instead of having to manually generate the thread dump or heap dump. So that is about the agenda today. I believe we have covered all the items in today's agenda. Let me just quickly walk you through the things that we have seen today before we move on to the Q&A session. We began by taking a look at different transactions. We performed some transactions. In fact, what we did first was we configured the Java agent and got it running. We hooked the application server to the agent, and then we ensured that the connection between the agent and the product is established. And then we used the Tomcat server to perform transactions on an online site hosted on this Tomcat server. We performed these transactions, visualized them in the product, and saw just the kind of information and the insights that it can reveal, and then how these insights can allow us to pinpoint errors to individual SQL statements, how stack traces can be generated, how error traces can be generated, and how to make use of them to resolve application issues. We saw the JVM performance of your Java applications, and then finally we saw how to configure a Java runtime monitor, why the Java runtime monitor is important, and the kind of metrics you can see beyond the JVM tab of APM Insight through the Java runtime monitor.